We're usually brought in when the house is on fire, right? I don't think it's an automated way how you migrate code bases. It's little pieces of value that I add, and that's how I progress from one stage to another. That's intense. Writing these tests beforehand, that's risk mitigation. The more coverage you have, the more accurate your parity checking is, the less risk you have at the end. AI is a differentiator. It empowers great software architects, software engineers that have a strong software architect system design capability versus those who do not. To write great software, you still need to be a great engineer. That didn't change.
If you're interested in system design and modernizing and migrating software, this episode is for you. I'm joined by Dennis Vink, principal consultant over at Xebia, and I loved learning from his approach, how he executes on the many ideas and projects that he has. So enjoy. I looked at your LinkedIn, and already in 2024, you landed assignments as AI engineer.
Yeah.
Was it all bringing AI to production, or was it more also kind of AI in way of working?
It was more companies wanting to learn more about AI, and the very beginnings. Models were pretty primitive back then, and there was not a lot of knowledge. What you see nowadays is that companies are much more self-sufficient.
Yeah.
They have a lot of knowledge internally about artificial intelligence. So now the assignments that you currently get are more complex.
Gotcha. Yeah, but it's still bringing an AI component to production.
Yeah,
somewhere within a product. Yeah. Can you share some of the examples that you've brought to production?
For example, knowledge bases are quite popular. So that's the interaction with the RAG system. And then the interface around it, how do you interact with it, response times, those type of things. But also like agentic data research. So you have a BigQuery database, for example, with lots of data in it. You want to get insights out of it. How do you do that? And how do you do that responsibly?
Yeah. I know you get a lot of energy out of building things. Can you share some of the examples of what you've built recently?
I have a lot of side projects.
Yeah.
One of them is Euroso, which is an agentic platform where you can automate business processes, which is really fun. Another one is a very old game that I played about 20 years back that I brought back to life. So I converted it from a binary and a bit of source code, which was written in C and C++, to Rust. And then a graphical user face around it, so you can play it in the web browser.
Nice.
That's really fun. Yeah.
How is your C, C++, or Rust?
Rusty.
Yeah, rusty.
Very rusty, yeah. I coded C and C++ maybe 30 years ago. So that's a long time. 30, 25 years ago, more or less. Then you evolve to other languages, a bit lower level languages, higher level languages. And the knowledge about these programming languages disappears.
Yeah. And that's not an issue with regards to bringing this piece of software back to life.
No, I can still read it.
Yeah.
And while you're working on such a project, the patterns are still familiar. And you know the principles, and you can write pieces of code. You can debug it. So it's like learning to bike. You don't forget it.
Gotcha. Yeah. So patterns, principles, those are the knowledge you need to be able to do something like this? Or how do you see that?
Yeah, absolutely.
Yeah.
I think if you you have the term vibe coding, right? It is a bit of it has a bit of a smear on the term because it implies being able to create applications without programming knowledge. Yes, you're able to do that, but you're not able to exercise any control over it. So if you vibe code something, you have zero knowledge. It will just go in the direction that the model thinks is best, and you're not able to assess quality, and you are not able to give the proper direction.
What do you assess in terms of quality, especially when we're talking about a piece of software that's written in a specific language and you want to modernize it? I feel like a lot of companies, or maybe even people, always migrations and modernizations are always a topic. But what fundamentals do you really need to have to be able to do this?
So you need to be familiar with test-driven development, for example. Let me take the game example, right? So I migrated an very old game from binary C++ to Rust, but you want to ensure that the mechanics are identical. So my approach has been to write tests, but also to use the code of both systems to assess whether what it reads and what it outputs, the actions that it does, that they perform identical when executed. So if it reads something and it parses something, in one system it needs to be identical to the other one, and that's how you prove parity.
And this is in an automated sense?
In an automated sense, yeah. So I created tooling for that to simulate, for example, in this game system, you have certain actions that trigger other actions. And then wrote a simulator like we trigger this action. Does it have exactly the same consequences?
Yeah.
And that's how you proceed. So that's kind of a brute force way, but that ensures that the end result is identical, even though the code base differs.
And these actions that you've specified in this way of working, are those actions upfront that you're saying these are the set of actions we need to validate, or are they also generated or randomized, or how do they come into place?
No, they're the actual code entry points in the original game.
Yeah.
Versus the new version.
Gotcha. Interesting. And looking at a perspective with regards to test-driven development, if the old code base didn't have any tests, do you then work to mature that to a certain level before you go modernize?
Yeah, absolutely.
Yeah. Interesting. Because a lot of organizations that I've looked at, people that I've spoken to, when it comes to software that they want to move away from, maybe there's a license component, maybe there's just a knowledge gap there, maybe they want to move to a different platform or a specific language. Typically those older code bases, they don't have that level of maturity. They don't have the test framework. That's why they want to modernize in the first place. And sometimes it's even, instead of a migration, a complete rebuild. And lots of those projects in the end fail because it's a huge effort and you need to really have buy-in from the business side, because in the end, it's a very long-term play. So moving away when the code base is not really mature, that's, I think, also part of the complexity typically.
Absolutely. Yeah. It's so writing these tests beforehand, that's risk mitigation. And the more coverage you have, the more accurate your parity checking is.
Yeah.
The less risk you have at the end.
Nice. Yeah. So the parity checking, that is mainly crucial, I guess.
Yeah.
You start with a code base, you make sure that maturity-wise, test-wise, you have a good safety net. Then you modernize, and you modernize in an automated way, I'm assuming. Does it matter which model or which methodology you use to modernize?
I don't think the model matters much.
Okay.
As long as it's a competent model.
Yeah.
Like I like to use OpenAI myself, Codex models, but you could use Claude. It doesn't really matter. Methodology does matter. You need to have the instructions in place, the parity tooling, and I think that begins before you migrate any actual code.
Gotcha. Yeah. How'd you come into this way of working? Is it just a lot of trial and error, experimentation, or?
Like I became an enthusiast the moment it went from large language models to agentic.
Yeah.
And I realized you could automate a lot of tasks with it. That's when I also got very interested in creating Euroso to solve to automate business processes, because I could see the potential of agentic. And so I became an enthusiast early on and started experimenting, and you see. As time progresses, these models get more and more powerful, especially with like the tool calling they can do and the accuracy on that.
Yeah, it's interesting because ownership is always a big thing, right? I put a lot of effort into my code base historically with regards to my commit message structure, the way we design systems and thinking about software architecture and applying patterns and keeping things simple and evolvable for the future. And I feel like a lot of those are kind of out of the water. And especially when we're talking about a modernization, if I go from Codebase X to Codebase Y in an automated kind of finger snap way, how much influence do I have on the structure, or should I care about what the code in the end looks like from your perspective?
Yeah, I don't think, like you say, in an automated way. I don't think it's in an automated way how you migrate code bases. So how I typically approach that is how you define like user stories. They're really scoped to a specific piece of value.
Yeah.
And that's also how I instruct the model. It's little pieces of value that I add.
Yeah.
And that's how I progress from one stage to another. And that's intense. Like, for example, the game server migration overall, including the web interface and an editor, took about a month of work. Not full-time work, but still a month of work of prompting, iterating, how you would do it as an engineer as well. You iterate on the product and you add little improvements gradually.
Gotcha.
So I don't think that differs much.
Yeah. Are engineers typically good at this? Because they have to step out of the hands-on part and more orchestrate things with regards to, you already mentioned user stories, and that's a lot of prompting, a lot of back and forth. Typically, that's not really what we historically have spent most of our time on. Most of the time has really been on actually building the thing and being in meetings to discuss about the thing and getting a better understanding. But that's more on the execution side of things.
Yeah.
Is that changing?
I think that is changing. And I think you will see that engineers that are like their velocity is limited by execution will love to be able to like zoom out a bit and have a whole overview and being able to orchestrate on that level. And you will have engineers that are in their little bubble that don't know how to do that.
You started creating code very early on, age-wise. You were there very early. And typically those are the people that really love the hands-on part of things as well. But since the hands-on thing is evolving, are you still getting the same amount of fulfillment? Or how do you see that?
I think it's accelerated, Like I have a mind that is always exploding with a million different ideas.
Yeah.
I have probably hundreds, if not thousands of unfinished projects.
Oh yeah? Still?
Yeah, absolutely.
That's never going to end. Yeah.
It's never ending.
Yeah.
And I always have different ideas that I don't have time for fleshing out. And this type of tooling helps me finally finish something. You get from A to Z quite rapidly, and it allows me to have that focus to finish it.
For me, I think I'm the opposite compared to you. When I start something, I really want to have the confidence that I can do this and actually finish things. So if I don't believe that I can finish something, I typically don't start many things, because I feel like, what's the point? If I start and I don't finish, I have to finish, or at least see it through to a point where I'm fulfilled. What would you advise people that are like me or similar that have trouble starting? Because starting seems effortless from your side. How do you make starting easy, or does it just come automatically?
Well, it comes semi-automatically. So I have a ADHD brain.
Yeah.
So that means that I start a million things and unlikely to finish all of them. But there's also the sense that I like the journey. Like I like the learning journey, the experience of creating. And a project doesn't necessarily need to end with a finished product for me. So it's also just having fun.
Yeah. Can we go through a scenario? You have an idea and you want to start something. What are some of the first few steps that you typically do with regards to starting?
First, I've also have a business background, so I do some research whether this already exists. Is it marketable?
Yeah.
Sometimes it could also be just a fun project for myself, right?
Yeah, like the game migration.
Like the game migration. So typically it starts with a bit of research, and then formulating a high level plan. Like, what do I want to achieve? What are my goals? What is the end state? And then drill down from there into more detailed steps. And usually along the way, I get a better idea of what I want to build. And sometimes that changes during the development process as well.
Yeah.
Like I get a great insight, like, oh, this could work better. And then now it's really easy to pivot. So in the past, if you are working on the project and you've invested months developing something, if you get a new insight that requires you to rewrite a large part of your code base, that is very demotivating because you've invested already so much time. So you have this sunk cost fallacy, which you also don't have now. So it lowers the threshold to pivot in that sense.
I've done, since I'm prompting a lot, I've installed like speech-to-text software on my laptop, and I just talk a lot more with regards to either brainstorming if I have to do something non-code related or if I have to do something software related. Still, I feel like prompting now and typing has become my bottleneck because of that interaction. I want it faster and faster to get the feedback faster and to get up and running faster. Is that something that you've experienced as well?
Partially, yeah. Especially also like due to the speed, like agentic coding is not instant. It's not like you prompt an LLM, you get an instant response.
Yeah,
and things take time. In terms of prompting, it's more the waiting for a task to be finished, to see, to evaluate, did it do what I want? And then reprompting or moving on to the next bit. And it's that wait that is a bit of a waste. You can mitigate that like doing parallel features, for example, that don't touch each other's code base or source files. But there's a bit of cutting loss, so to say.
Do you parallelize? So when you're working on one feature, let's talk about the modernization example of the game. You've defined your user stories. That's what you mentioned. Do you then see, okay, if we do these in parallel, these are not really going to touch each other? Or how do you approach that?
Sometimes,
that waiting period?
If I know for sure there's no overlap. But usually, like, for example, in the game example, I have a game server. I have a database layer. I have an editor, and I have a web client. And all of those four, they can use some work. So if I parallelize, it's usually on spread between those projects.
Gotcha. Yeah. So that's more defined boundaries rather than very close to each other feature-wise in the same domain. Yeah. What do you nowadays do while waiting? Because I feel like I am a little bit more waiting nowadays than actually executing. I read a lot based on the output, or I go do something else, but I am more in a waiting state, I feel like.
Yeah, usually. So I follow a bit along what it's doing, because it also shares like its AI thought process. And sometimes that leads to new questions or new insights. And then I go look it up, make a bit of research, for example, format of specific sprite library, for example, or thinking, maybe I want to support X and Y format, and then I go look it up if that exists, and how do you ingest that, for example. So it's reading up, and if I have nothing else to do, I will get distracted with something else, and probably forget what I was doing anyway, and then come back half an hour later. Oh yeah, I was doing that, and looking at the output again.
Gotcha. Yeah. I did a poll recently for the people that are listening. It was, what are your favorite topics on the podcast? And system design was the one that won. I think it's like 50%, and I had 4 options. So head and shoulders above the rest. System design for me is quite interesting. It's not something that I'm very good at because I've always come into projects where something is already live and now we're building on top of that. So a lot of artifacts with regards to system design have already been chosen. And unless we're bridging a gap with regards to a new feature that we have to do, there's not much thinking in advance. So my experience has not been from 0 to 1 that often. But I know throughout your experience, you've worked and focused on cloud, and also as AI engineer, you've brought a lot of stuff to production, not just in companies, but also in side projects. Do you think system design is still going to be one of the most core competencies for the people building, or how do you view that?
I do think it is going to remain important for sure.
Mhm.
Yeah, it's you need to have a strong foundation.
Yeah.
I'm a strong believer that you will see in the coming years that AI is a differentiator. It empowers great software architects, software engineers that have a strong software architect system design capability versus those who do not. I believe that the quality of what you create with these models is exponentially higher in great engineers versus those who are not well versed. Not to speak of the new generation. I worry for them.
Mm-hmm. Why do you worry for them specifically?
Because they will not be educating themselves in these principles anymore. Because it's like the FABO. It's take out, and you don't have these learning experience anymore.
Gotcha. What would you advise them then? Because you're saying software architecture and design principles, those are going to be important since you are more orchestrating rather than executing. What would you advise the new generation that's now learning or studying and coming up actually?
Go through the pain.
Yeah?
Yeah.
Do it manually? Is that what you mean? Or
do it manually.
Okay.
Struggle, make mistakes.
Yeah.
Preferably gapped from the internet, so you have no resources to look it up.
Okay.
That's the way how you truly learn.
Yeah, that's difficult. I feel like because the manual approach, it will no longer be what companies expect. I feel like if they will hire juniors, they will expect them to operate on a meaner level because you give AI tooling to accelerate people, to also accelerate their knowledge, but also their execution power. So then doing the manual route, especially on company time, I think that's going to be challenging.
It's going to be a hard bargain.
Yeah, right?
Yeah.
Yeah.
It's going to be a hard bargain. I think it's. I think great engineers are usually interested in writing software at a younger age, and I think that is when you make the investment. And I think the true cost of the accessibility, the availability of these models, is that new generations will have a lack of understanding of how to build software.
Yeah. Then looking at the industry, because I'm curious to hear how you see this. A few years back, you would be able to do a bootcamp, or at least this is what was out on the market. Bootcamp, 6 weeks, 2 to 3 months, education specifically for a core competency, meaning front end or back end, and then you would be marketable. That was the bootcamp kind of marketing strategy. And some people coming out of that bootcamp, they really got kind of hooked and they found fulfillment in creating and executing and building. And then they probably landed a job because there was a big demand for software engineers, for people that would be able to execute and create. I feel like the market is kind of flipped upside down. I don't know if it makes sense to go through a bootcamp with regards to core competencies or skills with regards to front end and back end anymore, kind of cookie cutter model, as compared to taking that same time and educating yourself and using tooling that is now out there to self-educate. How do you see that?
I think that's a good point. You had companies like Codebase, right? That educated developers. I've also personally seen a lot of very good people come out of there. Also people that drowned, that were not able to get this fire started in themselves.
Yeah.
And I don't know what is the difference between these people. Like what makes one person get really enthusiastic and deep into the matter, and others not. I don't know what the difference is. But I don't know where we're going. But
that's okay.
But I do think, I'm back on track. So I do think that people nowadays will have way more opportunities to educate themselves. There is a lot more information available on the internet, and people can experiment really rapidly, iterate really rapidly. So that might ignite that fire in them.
Yeah. I feel like one of the things I really underestimated coming into this industry was the amount of collaboration that I do within a team, not just within the business with regards to what are we building and why is that, but also throughout the team. There were a lot of interdynamics of working together and trusting each other and then letting things be with regards to what other people build and giving feedback and reviews. From my perspective, that is evolving. If I as individual have more building power, more execution power, then maybe instead of a team of 6, we can have a team of 2 or 3. And that is really shrinking. So then the focus I had on trying to fix collaboration, I feel like we'll be much more focused on the business side of things, trying to understand what are we actually building and why is that. I feel like that will be where software engineers are going to grow, not just going deeper on the technical side, but also on the business side, understanding outcomes more. You already mentioned when you start a new project, one of the first things you do is research from the business side and also seeing if it's marketable, which I thought was quite funny. And I also do that. It's because I think I like entrepreneurship. I like building something also in terms of outcomes. But I've spoken to many software engineers that are not like that also like building for the sake of building. And then when they've built it, that's it. Basically, that was the fulfillment. It wasn't the fulfillment that comes after. For me, it's the fulfillment that comes after. And those distinct parts, the building for the sake of building or the building for the part that comes after, I see those as very much 2 camps. And one will be happier, I feel like, with agentic tooling. And the other one, building for the sake of building, that is the part that is rapidly evolving. So I don't think those people will experience the same fulfillment anymore, which is, yeah, it's new. It's never been this crazy in terms of evolution.
No, absolutely. I think you're right. So that will be a big differentiator as well. But you don't know what happens when people get the headspace to think about these things. So when you have if you're more an orchestrator rather than an executor, so your role's changing. So imagine you're stuck in the old world, but you discover agentic tooling. You will get more headspace to also consider other things. Like I used to be someone that was deep into my code as well. That was my my whole world at that time. Along the way, I learned the ability to zoom out and look at the bigger picture, and I found enjoyment in that as well. But that's something you learn, and I think that learning process is accelerating as well. So that might also affect people who are not there now, but might be in the future.
Yeah. I'm wondering in terms of focus, because I always see myself as software engineer, no matter if I have the responsibility of a person that is responsible for product. At my core, I feel like I'm an engineer, but I also feel like there is a lot to focus on or be responsible for as software engineers in terms of knowledge. And one of the things I didn't really look at was system design, which I think is going to become more important. So I should put my time and effort into that. But system design as a whole, it's also, how do I make my software actually run, or what does it run on, and what are the underlying components of that infrastructure wise? I feel like infrastructure might be a good bet with regards to focus, because if building is accelerating, then yes, we will have more built pieces of software, but it still has to run somewhere. It still has to scale to a certain component, still has to be in the hands of users. And I feel like infrastructure is kind of the core competency there. I don't know how much innovation has been happening in terms of agentic solutioning for that front, or if people are still very much operating in the same way they did 2 to 3 years ago. Do you know?
I think it's like cloud infrastructure hasn't changed a lot in terms of core principles. It's become more accessible, so more people can easily deploy cloud solutions. But you're right. It is a core component, but it's also just a small part of the solution, right? So there is a phase where you do the infrastructure underneath your application, but that might be 2 weeks, a month, and then you have it running. In terms of like developing infrastructure as code, for example, agentic models can help with that as well.
Yeah. I did not do any infrastructure as code for a long, long time. And then I came into a project where that was part of the responsibility, and then using and leveraging agentic tooling because it is code it was quite powerful. For me to just illustrate and say, well, these are the things we need to change or what is out there in the first place, it was very good, actually, at identifying those things infrastructure-wise. Yeah.
Yeah, what I like about the infrastructure as code in general, it's a very deterministic world. So if I have a template, if I push it to test or production or to acceptance, it will behave identically because it's a deterministic template. It's declarative. With AI coding, that's not the case. It will write code, and if you prompt the same thing again, it will write different code. So that also has its appeal because it forces you to design the process and the tooling to fall into certain constraints.
Yeah.
So you have predictable output. So for me, the allure of cloud engineering was to create deterministic worlds, because I believe that determinism in development processes makes engineers happy, especially DevOps engineers who might otherwise be called awake at night.
Yeah.
And for example, for software migration or writing new software, it is I get fulfillment about shaping the constraints around it to produce stable code, high quality code, and scalable code.
Yeah. For people that have, then as an example, a code base that they want to modernize or they want to move away from, there's a lot of vendors that kind of hook you into a certain way of working with specific components, a specific code. And if that is 20 years ago, you might still be building on top of that, which can be quite substantial. When we're talking about absolute lines of code, it can be in the millions, basically. Also with regards to business logic and the complexity that is in there, you might have teams that are kind of maybe not even building features on top of it anymore, but just that are there as insurance to make sure it runs and they maintain it. Now there is an opportunity to modernize. And I feel like that modernization can be accelerated with tooling. You already mentioned that we have to make this deterministic or close to deterministic in terms of quality and outcomes. It can't just be a finger snap and then you have a new code base. And what is the outcome of that? It can be non-deterministic. So you have no clue if you can migrate or modernize or shift safely. But do you think this approach can work regardless of the scale of the existing code base?
Given infinite tokens, yes.
That's the constraint.
That's the constraint, yeah.
Interesting.
So it gets expensive really fast. To give you an impression, the amount of tokens I used for the game server migration runs in the billions.
Okay.
So that's a huge project, but it's also a big code base, right? There were more than, I would say, about 500,000 of lines, of code lines, assembly, C++, and some old Flash client. Like Flash is also from a previous era. The Flash client actually ran into the millions lines of code. It's very verbose.
Damn.
That's huge. So that takes a lot of processing power to process. But you do it in chunks. You do it in little chunks. I look at a specific set of functionality. I want to migrate this piece of functionality, this slide. And then create a plan for it. So I have an executable plan with checkboxes you can tick off, and I work on that in conjunction with the Parity tooling. And then when that piece is done, I archive the documentation for later reference, and also continuously do regression testing. So did my new change break something that I introduced before? So that's general my way. It's not a really fast process.
Okay.
So it's not like the snap and you have your new code base, but I think it's the best way of working to ensure that you produce something of value.
Yeah, interesting. The finger snaps way, that would scare me, right? Because if all of a sudden there's a new code base and there's no ownership, there's no people that are in between orchestrating the thing, but they still have to own it. That's just as like throwing something over the fence, basically. I don't think that would work. But this way of working, I'm assuming the same principles with regards to a modernization strategy would apply, right? If I have a piece of software or code base I'm modernizing away from, I'm going to look at my modernization strategy. I might want to migrate specific features first or deprecate certain things. I might want to freeze new functionality that comes on top of that, or figure out a way that can build in parallel, although that has risk. So you're going to do a lot of, I feel like it's a whole risk mitigation exercise, and that still needs to happen, even though you have tools that accelerate and you might not have to build hands-on yourself as much anymore. That would be my same approach. Still figure out what the modernization strategy should
Absolutely.
be. Then approach it from that way.
So imagine that you're building a product with an API, right?
Yeah.
And you build functionality on top of that, or you deprecate certain stuff from that API. You would still have to think about the same principles. I need to deprecate that endpoint, or I need backwards compatibility. And you need to safeguard that that is actually built in.
Yeah.
So do the actual checks. Do the API still do the same? If I call the new API with old post parameters, does it return exactly what I expect? It's easy if you have the code of the old API versus the new API to write a tool that automatically checks that. Like, oh, these are the possible input values. And you can do assertions, right? So if I post this combination of values, I expect this result. And if not, there's an error in the API. So you can instruct the agents to actually leverage that. Maybe even run simulations for combinations of post parameters. And then say, does it in each instance return what I expect? And if not, revise and fix the error. Yeah,
interesting. I really want to work with this in a production kind of sense. And I'm now at a client where I have the opportunity to do so. So this is going to be fun. Is the magnitude of things and the teams that are involved in the Codebase scope. I wouldn't know where to start, and we're probably going to run experiments, but I like your suggestion of, if the Codebase is not as mature in the current state, you need to work on the maturity side of that first. So looking into the existing flows and creating tests around that, or at least scaffolding around that.
Absolutely, but also so not only maturity in the sense of tests and Parity tooling, but also documentation, which is often lacking.
Yeah,
like the more the agent knows about the structure of the old project, and the so the structure and the layout, the better.
How much of this do you do manually, or how much do you rely on kind of your agent to give you input into structure and formalize that, is what I'm still wondering.
So when starting up, there's a lot of manual input. Because I have a particular idea about how this document should be structured, what should be in there, what is important and what is not important. Whereas an agent does a wild guess based on inferring from the source code. But I have a more high-level overview of what this code base is, and what all pain points will be. So I make sure that the most important points are documented well, and then have an agent revise it once I have the base in place.
Nice. Yeah. I want to talk about risks and pick your brain on that front. I've heard a narrative, I don't know if it was in person or online, because sometimes those blur together, but that certain agents are not as good when it comes to specific programming languages. You already mentioned C, C++, from the example of modernizing the game code base, Flash as well. Is that something that you've experienced in practice? That, for example, Rust, since it's a newer quote-unquote language, it's not as good as?
I found migrations to Go to be much better than Rust.
Okay.
Like Rust, it would often lead to compile errors because it's Rust.
Yeah, that's Rust. Yeah,
that's Rust.
Also, if I do it manually.
yeah, exactly. So that takes a few iterations before it compiles in the first place. Whereas Go, I rarely have compile errors if I have an output Go code. I don't think it has a lot of knowledge about Flash in general, the models that I use. Also, nobody uses Flash, so why would
makes
it?
Sense. Yeah,
makes sense. But it could infer from most of the principles. Like the Flash client I migrated to HTML JavaScript.
Okay.
It got the base right in one shot, but particular implementation details it did not. And then that took quite a few iterations to get right.
Gotcha. Yeah. And then when we're talking about risk, I feel like hallucination is still a thing. It's getting better and better. But how do you build around or with hallucination in mind, accommodate for that?
That's the test tooling.
That's all the scaffolding is basically, is it just for the non-deterministic part?
Yeah.
I assume so, right?
Yeah.
Nice. The same feature parity sense, I could still do regardless of any code base, right? Because Codebase will have features. You have a structure around figuring out if the old code base behaves the same as the new code base. So I don't see feature parity working differently for different pieces of software.
No.
But how do you build on top of that? Because the existing code base for me, feature-wise, has everything. It's complete. That's what you're modernizing away from. But the new code base, you're going to incrementally build up in terms of features. Sometimes it's just a ball of mud and features kind of are very much interwoven. How do you accommodate for that when you're moving to a newer code base?
So the advantage of the approach I described is that you already have your tests written, right? In your old code base, because you're maturing that. You already have your Parity tooling running properly.
Yeah.
That also means that in the new code base, you will also have tests already written, and you will have regression tooling that checks whether a change that you made, whether that leads to a regression bug, for example. So that makes it really easy to iterate on it. And if you are going to continue with agentic coding on the new project as well, which I then assume, is the advantage is you can use the same pipeline. And you can codify that into your documentation that needs to happen every time a build is run, for example.
That newer way of working, if we have an existing code base, you can structure it in a way that agentic tools work quite well. There's a narrative online on skills versus agents and how much documentation is too much documentation, how explicit you need to be versus relying on implicit model knowledge. I feel like years ago, you had to be very explicit, but nowadays there's a lot of implicit model knowledge. The way of working that software engineers are going to go about is very much changing. I'm on the train of, I feel like spec-driven development is quite effective. If I put my time and attention in building a spec, and also a spec is quite arbitrary. I've noticed people have different interpretations of what it is to create a specification. But if I have a very solid spec that actually aligns with the feature that I'm trying to build, then the building of things is actually quite reliable. If I have really good conventions, that is even better. And if I have the right scaffolding and the right kind of safety net in testing and resilience, that's the best, to be honest. So I really see that as kind of, at least right now, how we're going to operate in the future. What is your view on that?
Yeah, I think that'll evolve, right? So absolutely. I have a fun anecdote. 2 weeks ago, I had a session with a colleague of mine who works for Xebia. And she had an idea for 10 years to create it's for the real estate market. But she's not technical. So she asked me and another colleague to help her out with AI to create this application for her. What I did instead is show her agentic coding. How does that work? I set up the base for her. Like, this is how you structure your project. Here's how you create a plan. And then the first iteration, I instructed the model to create a plan from her. She had a document with functional requirements, which was quite elaborate. And the model created a implementation plan from those functional requirements, and then started implementing them. And within the hour, there was a POC application that she could already showcase to a venture capitalist for investment, for example. But then I gave her the reins. I said, now you're going to do it. She prompted the next bit of functionality. And then I uttered the words, "You are now a developer." And she lit up. She realized she was now, she had the efficacy to execute on her vision. So I think that's a great way for her to start. And now she understands. She's still not technical, but she knows how to structure her project, how to iterate on it, how to create new versions of her application to make her vision come true.
Yeah.
I don't know if that answered your question, but it's something I had to think about when you said that.
It made me think of another question, because I know topics like these can be quite controversial for different audiences, but especially the people that have gone through education with regards to software or have years of work experience under the belt, right? If you would say she's now a developer, there are many people that would say, actually, she's not, because she doesn't think about X, Y, and Z. But I do agree that this build process, that's the part that gets a lot easier. So I'm very much wondering then, when do software engineers, or the people that currently are engineers, come into play? Is it when it reaches a certain level of scale? But the people that are driving, they will never realize that, okay, this is when you actually need certain foundational knowledge or expertise. There was a LinkedIn article on someone that made an app, and the app was actually, people had to upload their pictures, and it was kind of a social network app, and it was completely orchestrated and built in the way that you exemplified. And then there was a security breach, and all the images got leaked and stuff like that. So that will definitely be concerning, I feel like. But I don't have an answer for that yet.
No, we're usually brought in when the house is on fire, right?
Yeah.
That's when you need real software engineers.
Damage control. Yeah. That's it. That's the reality.
Yeah. No, so I took the phrase, "You're now a developer" from Netlify.
Yeah.
You're probably familiar with it. That's what you see the first time you deploy an application to Netlify. You're now a developer, and the idea is to empower people, to make them enthusiastic, so they deep dive more. Of course, to write great software, you still need to be a great engineer. It didn't change.
Yeah. Thanks so much for coming on, Dennis. This was a blast. I love picking your brain on modernizations and just your general principles on building nowadays.
You're more than welcome.
Cool. We'll round it off here. If you're still listening, let me know in the comment section what you thought of this episode, and we'll see you on the next one.